This is the review for your first test of the year on decimal and integer operations. You'll typically receive the review packet with one night to work on your own, which doesn't mean you should try to finish the review. You can't really do it the whole thing in one night, but it gives you a chance to preview and try some of the problems on your own and bring it into class the next day, where we'll begin what is typically a 2-day in-class review. And so it benefits you to have previewed the problems and try them on your own. You shouldn't expect to be able to do every single problem. I designed the review to be very challenging, and so don't be alarmed if there are some problems you cannot do at first. We'll work on the review in class together for 2 days, and you should be watching these videos after you've tried the problems on your own. There's one video for every single page of the review. Unlike the support videos for your learning opportunity assignments, you're not required to watch the entire video for the test review. Maybe there's a particular problem you're concerned about, and maybe you fast forward to that problem, and they can help you study in that way. Don't forget to get your test review signed by your parents. It shows your parents that you have an important upcoming test, and they can see that you've worked hard to prepare for that test by getting the review signed, and that will give you 2 bonus points on the test if you get it signed. We'll begin our test review with problem 1 right now. Problem number 1 reminds you of the definition of subtraction. So this is something that's in your notes that we've been working on, and you will be tested on this, understanding that subtracting is the same as adding the opposite. And so we can apply that definition of subtraction to integer subtraction situations to make them easier. So we'll change each subtraction expression below to addition and then solve it. So subtracting is the same as adding the opposite. So I have negative 17 minus 28. That's the same as negative 17 plus. Subtracting is the same as adding. The opposite of whatever I was subtracting, I was subtracting 28. The opposite of 28 is negative 28. And then we know from the number line model we used, or the chip model, that if I have a det of 17 and a det of 28, that's you're just combining those 2 debts. If you started at negative 17 on a number line and you added negative 28, you would go 28 more to the left. So you just find the sum of those two, 28 and 17, is 45. And so you just have negative 45. Problem B, 50 minus negative 4. Again, subtracting is the same as adding the opposite. We were subtracting negative 4. The opposite of negative 4 is positive 4. 50 plus 4 is 54. Here we have an expression with subtraction followed by addition. I think first let's evaluate this absolute value. If you remember our work with absolute value, it means how far is this number from 0 on a number line. Even though negative 20 is in the negative direction, its distance from 0 is 20. So the absolute value of negative 20 is 20. So I'll just substitute that into our expression, and then we'll take it from there. We have this integer subtraction, negative 9 minus 12 is the same as negative 9 plus, because subtracting is the same as adding the opposite. The opposite of 12 is negative 12 plus 20. Negative 9 and negative 12, that's a lot like this problem. You're just combining the 2 debts. It's just becoming more and more negative, and then the sum of 9 and 12 is 21, so negative 21. Negative 21 plus 20 is, if you look on let me do this real quick. If we look at a number line, use 0 as a reference. If I'm all the way over here at negative 21, that far to the left, if I add 20, it's not going to get me far enough to get to the 0 or beyond. So I'm not going to be in positive territory. I'm going to have moved 20 steps toward the 0, which leaves me off at negative 1. I've increased by 20, but I'm still in negative territory. Or you could think of the chip model, where we would have 20 0 pairs and 1 red chip left over. Or you could just find the difference between 21 and 20, which is 1, and then realize the absolute value of negative 21 is greater than the absolute value of 20. So since it's farther from 0, our sum is negative here, so -1, any way you think about it. Problem number 2. This is a quantitative comparison problem. You're going to see these, you have been seeing these, and you will continue to see them on the ERB test, but they're also on the SAT that you'll take when you're a junior in high school, so it's good to get used to this format now. Whenever you have these quantitative comparisons, you're trying to identify the quantity in box A and compare it to the quantity in box B, and you're going to answer multiple choice, either A is greater than B or B is greater than A, or they might be equal, or in some cases there's not enough information to tell which one is greater or whether they're equal. Box A says the difference between two negative integers, but they haven't told you which two negative integers, so just pick your own two negative integers. Like, I'll just pick -3 and -2. The difference between -3 and -2 would be -3 minus -2, and then let's apply the definition of subtraction that we used on problem 1. Subtracting is the same as adding. The opposite of -2 is +2. So we could change this to -3 plus +2. That would be -1. So if I'm testing this with these negative integers, I get -1. And a positive integer would be to the right of 0. So in this case, A would be less than B, or B would be greater than A. But we can't circle that answer choice yet, because one of the tricky things about these kind of problems is you have to consider, it said the difference between two negative integers. Well, I chose to subtract a negative integer that was less than this negative integer. Like, in other words, I subtracted a greater number from a smaller number with this first choice, but I could have started with -2 and subtracted -3. There's still two negative integers, and I'm still finding the difference. If we check this, this is the same as -2 plus, because subtracting is the same as adding the opposite. The opposite of -3 is +3, and -2 plus 3 is 1. So in this case, this is +1. So if this positive integer over here is 1, then they would be equal. But if the negative integers I chose were where the first one is less than the second one, this is the minuend and this is the subtrahend, but if this is smaller than this one, then you get a negative. So sometimes A is less than B, sometimes A is equal to B, and there would be some negative integers we could choose where A would be greater than B. So this is a case where there's not enough information to tell which one is greater. That's a very challenging problem, and probably a new idea or a new type of problem that you haven't seen before, where you have to try different values, but we'll be practicing with those this year. Problem 3 is a bit more straightforward. Find the value of the expression below. Anytime we have an expression with multiple operations, we should think about PEMDAS. Parentheses happen first, exponents next. Multiplication and division happen at the same time. They're inverse operations. Their division is multiplying by the reciprocal, so you just do the first one you see as you move from left to right. And addition and subtraction are handled the same way. That's step 4. So we need to recognize that this fraction bar indicates division. So this says 125 divided by 5/10. Once we know that quotient, we're going to subtract the product of -1 2/10 and 7. So anytime you're simplifying an expression, you should leave all this vertical space empty. You shouldn't be doing your computation right here. You want to be able to substitute this quotient underneath here, this product underneath here. So I'm going to do the computation on the side, and you can follow that, or you can, that's just good advice for minimizing errors. So here we have 125 divided by 5/10. So that's 125 divided by 5/10, but I don't want my divisor to be a decimal when I'm using long division. I can multiply my divisor by 10 as long as I also multiply my dividend by 10. So the decimal in 125 is at the end because it's a whole number. I multiply it by 10 by moving the decimal 1 to the right, and then I show a 0 in the ones place. And now I have 1,250 divided by 5, and I can just go ahead and divide. There are 0 5s in 1. There are 2 5s in 12. 2 multiplied by 5 is 10. Subtract, you get a difference of 2. You bring down the 5. How many 5s are in 25? Exactly 5. 5 5s is 25. Subtract, you get a difference of 0. But we're not done yet, because this decimal that I moved, I should have lined it up in my quotient, because that tells me that I still need one more digit. How many 5s are in 0? 0. 0 5s is 0. 0 remainder, so this quotient is 250. 125 divided by 0.5 is 250. And we're going to subtract the product of negative 1 2/10 and 7 from that. If we look at PEMDAS, we can't subtract until we find this product, because this is multiplication. Negative 1.2 times 7. So I'll do that next. We also learned that a negative multiplied by a positive is a negative, so I'm not going to, when I write my 1.2, I'm not going to write it as negative. I'm just going to find the product and then realize that I have the opposite of 1.27, so I'll just make it negative at the end there. 2 7s is 14, carry the 1. 1 7 is 7 plus 1 is 8. I was multiplying tenths times wholes, so I should have tenths as my answer. There's one decimal place here, none here. So 8.4. And again, a negative multiplied by a positive is a negative, so this is negative 8.4. And that's what we're subtracting from 250. Then you need to remember the definition of subtraction. Subtracting is the same as adding the opposite. So this is 250 plus the opposite of negative 8.4 is positive 8.4. So the final answer is 258 and 4/10. The last problem on page 1. Number 4, at the state fair, ride tickets can be purchased for 35 cents each. Each ride requires a certain number of tickets. Axel wanted to ride 2 rides and eat a Krispy Kreme cheeseburger. The burger cost $4.75, and the rides required a total of 13 tickets. Write and solve a mathematical expression to determine how much money all this fun will cost Axel. So we have this cost of 35 cents per ticket, but we're buying 13 tickets. So when we write our expression, an expression does not include an equal sign. So we have 13 tickets multiplied by 35 cents per ticket. And to that we add the cost of the burger, which is $4.75. If you had a problem on the test like this, you'd be getting points just for writing this expression, because it tells you to write and solve the expression. So if you're just doing computation on the side, and then you put it all together at the end and you never write this expression, then you're not doing everything the problem's asking. If we're multiplying 35 cents by 13, you really don't, when you're multiplying with the decimal, when you're multiplying with the decimal, you don't need to line up any decimals. You can just multiply as if you're multiplying 35 times 13, and then we deal with the decimal at the end. Hundredths multiplied by wholes will give us hundredths. 5 3s is 15, carry the 1. 3 3s is 9, and 1 is 10. Then I start with a 0 because now I'm multiplying by tens. 5 1s is 5, 3 1s is 3. Should cross that out, and I get a total of 455. But like I said before, we were multiplying hundredths by wholes. That will give us a product in the hundredths. There are 2 decimal places here, 2 digits after the decimal. 0 decimal places here because I'm not showing any of the digits after the decimal. So I need 2 decimal places in my product. So this part of the expression, this product is $4.55. And then if I think about whether this seems reasonable, 0.35 is pretty close to 0.33. It's about a third. And a third of 13 is a little more than 4, because a third of 12 is 4. And so this seems like a reasonable amount. And then to that I add the $4.75. Now we're adding with decimals. So now we do need to line up our decimals. 455 plus 475. Line up your decimal in your sum. 5 and 5 is 10, carry the 1. 7 and 5 and 1 is 12 plus 1 is 13, carry the 1. 1 and 4 is 9. So this is a total of $9.30, and you should include these units, dollars. This could have been done using mental math pretty easily, because 475 plus 25 cents is $5. And then if I take 25 cents from this 455, I'm left with 430. So $5 plus $4.30 is also $9.30. Okay, that completes page 1. I appreciate your effort studying for your test. We'll pick up the review with page 2 on the next video.